AOPS number theory 12.30. Find the remainder when 7 to the power of 255 is divided by 11. So 7 to the power of 10 is congruent to 1 in modulo 11. If you can write that, you can test it out by just like doing all of it, like just doing it. But I'm not going to write that because it's going to take a long time. So 7 to the power of 255 is equal to 7 to the power of 10 times 25 plus 5, because this is equal to 255, which is equal to 7 to the power of 10 in brackets to the power of 25 times 7 to the power of 5, which is congruent to 1 to the power of 25, since 7 to the power of 10 is congruent to 1 modulo 11. So it's congruent to 1 to the power of 25 times 7 to the power of 5, which is 16,807, which is congruent to 1 times 10. Since this is congruent to 10 in modulo 11, which is congruent to 10 in modulo 11. AOPS number theory 12.32. John tells Susie that he's thinking of an integer that leaves a remainder of 2 when divided by 6. Susie correctly informs John that the number is not a perfect square. How does she know? So first we're going to square each modulo 6 residue. So 1 squared is leaves a residue of 1. It ends with 1. 2 squared is 4. 3 squared is congruent to 3. 4 squared is congruent to 4. 5 squared is congruent to 1. 0 squared is congruent to 0. So these squares only have residues, residues 0, 1, 3, and 4. So there's no perfect square with remainder 2. So that's how Susie knows that when it has a remainder of 2, it's not a perfect square. 12.35. Find the smallest natural number n such that 617n is congruent to 943n in modulo 18. So since it's congruent to each other in modulo 18, that means 943n minus 617n divided by 18, which is equal to 324n divided by 18, which is equal to 163n divided by 9 is an integer. So that means n must be a multiple of 9 since 163 isn't. So the smallest value of n is 9.